Okay, chemistry and light. So I'm going to ask you to be able to figure out a couple of things from light, including a wavelength and frequency, and also the energy. So this is really important, especially when we get to figuring out electron movement and where light comes from. But for right now, we need you to be able to do these calculations and understand what it means. So again, we're dealing with electromagnetic radiation. So you're familiar with visible light, but also everything. So gamma rays, X-rays, ultraviolets, microwaves, radio waves. All of those are qualified as electromagnetic radiation. It travels through the vacuum of space, sort of unlike sound, which doesn't travel through space. For the first part, we're going to think about light in terms of waves. So we can describe light in two different ways. One way is in terms of a wave, like an ocean wave, which is going to have a wavelength and a frequency. And these are the definitions, but importantly that we have this equation, this wave equation, which says the speed or velocity is going to be equal to the product of those two. So when I multiply wavelength and frequency together, I can get the velocity, and for light, it's always going to be the same. That is going to be the speed of light. Okay, a couple problems. So what is the frequency of light that has a wavelength of 3.4 times 10 to the minus 4 meters? So here's what I'm asking you to do. So I'm going to ask you to write down what you've been told and the constants you're going to use. So in this case, the wavelength, I'm going to use the right variable for the wavelength. There's upside down y or lambda symbol. This is going to be 3.4 times 10 to the minus 4 meters. Right? The other thing I know I need to use the wave equation, right? So I have wavelength, I want to get the frequency. I know the speed of light, and I'm always happy to tell you what that is, or you can look it up, 10 to the 8th meters per second. And lastly, write down what it is that you're looking for. What is the unknown that you want to find? So in this case, I'll be using the wave equation. So frequency times wavelength is equal to the speed of light. I want to get to frequency, so I'm going to divide both sides by the wavelength. Notice this cancels. And I'm left with my frequency is equal to the speed of light over the wavelength. And now I'm ready to plug in some numbers and see what I get. So I know the speed of light is 3.0 times 10 to the 8th. And the wavelength is 3.4 times 10 to the minus 4. And when I plug it into my calculator, I'm going to get 8.8 times 10 to the 11 hertz. Give it a try, make sure it works out in your calculator. So sometimes you have to put parentheses around things in your calculator to make it work out. And I like using the E, remember, times 10 to the power of. I can write this in my calculator as 3.4 capital E negative 4. Sometimes it's called EE or EEX, depends on your calculator how it's done. So that's one situation. So I was given wavelength. I wanted to get the frequency. So we could do the other side. So I'm given. I want to find wavelength, and I've given the frequency. So the second question says what is the wavelength of light that has a frequency of 2.4 times 10 to the 12th hertz, right? So big numbers. You're not going to be able to type 12 zeros into your calculator and have it work out. So let's give it a try. So just like this one, I'm going to go through the same steps. And so what I'm asking you to do for these problems. So show me how you got the answer. So what was the variables you started with? What was the equation that you used? Plug those numbers in. Show me what you plugged in and where you plugged it in. And then that's the answer. And to be complete, you should circle the answer, right? So this will get full credit. If you give me just the answer, I'm not giving you any credit. Sorry. You got to show me how you got there. So, all right. So frequency is equal to 2.4 times 10 to the 12 hertz. This is what they told me. I continue to know the speed of light, which is 3.0 times 10 to the 8th. In this case, I want to find the wavelength. That's my unknown. I'm going to use the same wave equation, but now, instead of solving for frequency, I'm going to solve for wavelength. So in this case, I'm going to get wavelength all by itself. Frequency would cancel, and my wavelength is going to be the speed of light divided by the frequency. I'll plug in some numbers, 3.0 times 10 to the 8th. And I'm going to put 2.4 times 10 to the 12th here at the bottom. So that's my frequency, right? So if you get this correct and laid out the first time through, then this is, you're guaranteed to get the right answer. So I'll plug this into my calculator. I get 1.25 times 10 to the minus 4 meters for that. That's a 4, and I'll circle that. Okay, so this is the wave equation. This is using the wave equation, and if I know one thing, I can get to something else. This is thinking about light in terms of wave properties, right? So we're treating it like a wave. We can also treat light like a particle, right? So essentially a packet of energy. This is a valid way of doing it, and we call this a photon. So when we think about a packet of energy coming, we have another calculation that allows us to get to energy. So this is the energy equation, which uses Planck's constant in it. And Planck's constant is this really tiny number, but it makes it all work out. So we're dealing with tiny things, so we get tiny numbers. So anyway, so it says Planck's the frequency equation. This equation tells us that energy is proportional to frequency. So I'm going to ask you to do some problems. So there are, I think, 8 problems I'm going to ask you to do to get a little bit comfortable with this and get comfortable with some of the math that's involved. And this is a couple things that are going to be available to you. So I'm happy to always tell you the wave equation. So that's the first one here. The speed of light is equal to wavelength times the frequency. And happy to tell you the speed of light. I'm happy to tell you the energy equation and the energy constant. These other two you won't need. So happy to tell you these things. But here's a strategy. So there are 3 different approaches that might come up. So one, if you know the frequency and you want to find energy, then you want to use this energy equation. I'm just going to plug the frequency and multiply it by Planck's constant to get energy. If you know wavelength and you want to get to energy, well, you've got to do one extra step. So in which case, I'm first going to find frequency, and then I'll use that frequency in the equation, in the energy equation, to get to energy. And the other thing we could do, we could go backwards, right? So I could tell you energy and ask you, well, what is the wavelength of light that came from? In which case, we need to go through 2 steps again. So if I know energy, the first thing I'll do is find frequency. Here's the form of the equation that you use. And then with frequency, I'll then use that in this wave equation to figure out what the wavelength is. As promised, let me go through 2 examples of what this is going to look like. Where did it go? So, weak time chemistry. Yep, here it is. So let me do problem number 2. So it says find the energy in joules. That's how we measure energy in joules per photon of microwave radiation that has this this value, a frequency of 7.91 times 10 hertz, right? So this is the simpler case, right? So I'm going to go to, they're telling me frequency. I don't want to find energy, so I'm just going to plug it into this equation and find the energy with that. So here we go. So again, I'm going to write down what I'm looking for. I'm looking for energy, and they're telling me the frequency, which is 7.91 times 10 to the 10 hertz. Planck's constant, I'll need that, is 6.63 times 10 to the minus 34 units of joule per second. And I'm going to use the energy equation to figure this out. And I don't have to rearrange anything. I'll just plug numbers in. So constant is 6.63 times 10 to the minus 34. Frequency is 7.91 times 10 to the 10th. And I'll plug it in my calculator, and I'll get 5.24 times 10 to the minus 23. And again, it's energy, so I want to make that joules in the end. Joule is our measurement of energy. So it takes about 4 joules to raise 1 gram of water by 1 degree Celsius. So joule, this is a really tiny amount of energy, right? But we're talking about light, and light's a really tiny thing. That photon is a really tiny packet of energy. So again, this is what I'm asking you to do. So to get full credit, I'll ask you to show me what you used, how you used it, and then the answer. Okay, the last one. Let's do one more. So what do we have here? So let's do number 6. It says a ruby laser produces red light with a wavelength of 5 times 10 to the minus 7 meters. Calculate its energy in joules. Okay. Well, let's think about this. They're telling me the wavelength, and I want to get to energy, so I'm going to have to first calculate the frequency, and then use that to calculate the energy using the energy equation. So here we go. So they're telling me the wavelength is equal to 5 times 10 to the minus 7 meters. I want to find energy, and I'm going to need the speed of light at 3.0 times 10 to the 8th meters per second, and I'm going to need Planck's constant 6.63 times 10 to the minus 34. I'm going to look up on the sheet, and it's going to tell me that To determine frequency, I need to take the speed of light and divide it by the wavelength. So to get frequency first, I'm going to take the speed of light, 3.0 times 10 to the 8th, and I'm going to divide it by the wavelength, 5.0 times 10 to the minus 7. And I'm going to get a frequency equal to 6 times 10 to the 14 hertz. So this is my value for frequency. So I'll put this over here. Right? Frequency is 6 times 10 to the 14 hertz. And we'll get big numbers for hertz, so frequency can be quite large. Frequency on a microwave is on megahertz, so millions of hertz. Okay, so now I want to get to energy. So energy is going to be Planck's constant times the frequency. I know those two, so I'm just going to plug them in. So it's 6.63 times 10 to the minus 34. I'm going to multiply this by 6 times 10 to the 14. When I plug that into my calculator, I'm going to get something around to 4.0 times 10 to the minus 19 joules. Again, be careful getting it into your calculator. You got some really weird numbers, so getting these into calculators starts as a challenge and you need to figure it out for this class, and I'm happy to help you. So anyway, this is the answer for question number 6. Again, I'm asking you to show me how you got there, and there's only 6 more for you to go. Hope that helps. Bye.